Let's take a look at a particle motion problem. This is from the 2012 free response section. They give us a velocity function cosine pi over 6 times t at x equals -2, or excuse me, the position is at x equals -2 at time equals 0. So that's an initial condition, and it's on the interval from 0 seconds to 12 seconds. And the first question is, when is the particle moving to the left? So if you will recall that if velocity is positive, we usually say that the particle is moving towards the right, and if velocity is negative, it's moving to the left. So we need to look and see, when is this particle, or when is the velocity negative? Now be careful here. You don't need to start taking the derivative or the integral in part A, because they've given us the velocity function. So what do we need to do? We need to consider, when is pi over 6 times t, when does it equal 0? Well, let's take a look at it. When does cosine itself equal 0? Well, cosine equals 0, just cosine of x. It just equals 0 at what? At pi over 2, 3 pi over 2. Just a quick refresher. This is the unit circle, and we're looking at 0, pi over 2, pi, 3 pi over 2, and then once we make the full circle, it's 2 pi again. Cosine is this angle here. Cosine is what? Adjacent over hypotenuse. What, 0, our triangle would be here, and so at 0 the cosine is equal to 1. At pi over 2 it doesn't have an x component, so its cosine is 0, so that's why it's pi over 2. Alright, so how do we get this pi over 6 times our variable t? How do we make it equal pi over 2? Well, if this is 3 seconds, 3 over 6 reduces to 1/2, right? And then again at what? If we choose 6, 6 over 6 reduces to pi, so that's not a candidate. So the only other choice is at 9 seconds. 9 over 6 reduces to 3 over 2, which is this guy right here. And then when we get to 12, 12 over 6 is 2 pi, and that's equal to 1. So the only two times that it happens is at 3 seconds and 9 seconds. So we just need to look at what's happening on these intervals. So to the left of this, a good candidate would be what? Let's just go right to 0. Well, what is the cosine of pi over 6 times 0? Well, that's equal to 0. The cosine of 0 equals 1, which is clearly positive. So it's moving to the right on interval from 0 to 3. And then let's pick something between 3 and 9. Well, pi over 6 times 6 would be an easy one, right? That reduces to the cosine of pi, and the cosine of pi is a -1. So it is moving to the left between 3 and 9. And then we could go out and just double check at 12, right? So we have pi over 6 times 12. That reduces to 2 pi. 2 pi is where the cosine is equal to 1 right here. So it's moving to the left on the interval from 3 to 9. So we could maybe just make a statement like this. And that should be sufficient right there. Okay, the second part says the total distance traveled in the first 6 seconds. They want you to set up the integral but not to evaluate. So we know we need to look at, first of all, we have PVA, right? And we go this way, we're taking the derivative. And when we go in this direction, we're going to take the integral. Well, the integral is also the accumulation function, where it's basically adding up the distances. But if we just take the velocity, remember this is the area under the curve, and if you'll recall, it's possible for a graph to have some positives and negatives, right? And so if you add them up, you have positive values and negative values, so those two things sort of subtract from each other. Well, they're asking us to find the total distance traveled. So the total distance traveled means we have to add up the positives and also add up the negatives, but have to have the absolute value so that we can find the exact value. So I think a statement like this might suffice, where you can say the integral from 0 to 6 of the absolute value of velocity, and that should do you right there. Alright, of course this problem has 4 parts. The next part says find the acceleration at t equals 4. Let me move this up. And then it wants us to do what? Find whether the speed is increasing, decreasing, or neither. Alright, so we are sitting right here at velocity, right? And we want to go to acceleration, so we have to take the derivative of the velocity function. So the velocity function equals cosine pi over 6 times t. Take the first derivative will take us to the acceleration. So acceleration equals the first derivative of cosine. And the derivative of cosine is a negative sine pi over 6. And this is a chain rule, so you have to take the derivative of the inside portion. The derivative of pi over 6 times t is just positive pi over 6. And now we need to evaluate it at what? Evaluate it at time 4. Alright, so we have, cleaning this up, we can pull this negative pi over 6 out in front. And the sine of pi over 6 times 4 seconds. That 4 reduces to what? 2/3 pi. Okay. And unit circle time. Pi over 3 is right here at 60 degrees. 2 pi over 3 is over here. The sign of this is positive, right? Because sine is built on the letter y. And using your hand trick, just take the sine of pi over 3, which is what? The square root of 3 over 2. Multiply that by a negative pi over 6. And looks like we have that the acceleration is equal to what? A negative pi times the square root of 3 over 12. Alright? So we don't know if it's speeding up or slowing down because we just know that it has a negative acceleration. But if the velocity is negative, then it's speeding up. If the sign of velocity is positive, it's opposite of this acceleration, so then it would be decreasing. So we have to take a look at the velocity at time equals 4. So right here is our velocity function. So let me see if I can squeeze it in above here. So we have the cosine of pi over 6 times 4 seconds. Of course, that's just the cosine of 2/3 pi. Cosine of 2/3 pi is what? Over in this quadrant, cosine is built on x, so this is negative also. We really don't have to do anything further. We don't have to find the exact value, although it would be a -1/2, right? You could say the velocity. Say the velocity at 4 seconds is equal to a -1/2. Since the velocity is moving towards the left and the acceleration is negative, if this particle is speeding up at time equals 4. Okay. And finally, the next part says find the position at t equals 4. You recall that they gave us a key piece of information. They said at t equals 0, the position was, I believe, -2. Let's go back up and check that. Yeah, -2. So the function from 0 to 4, if we're looking for the position, not the distance traveled, but we're just looking for its position, it's going to be equal to the integral of the velocity, and we have to also consider where does this thing start out. It doesn't start off at the origin, it starts off at -2, so it's -2 plus this value, and that would be our position at 4 seconds. So basically, we're just going to add a -2 to our answer. Okay, well, the integral of this is what? Positive sign, pi over 6 times t, but this is not just, we should probably slow down a little bit. We're going to make a u substitution here. U is equal to pi over 6 times t, and du dt is equal to pi over 6. Cross multiplying, you get that du is equal to pi over 6 times dt. So what would dt equal? 6 over pi times du. So now if we do a u substitution, we would get what? We would get this constant out in front, 6 over pi, 0 to 4 of the cosine of u, du. Alright, now we can continue taking the integral of this, and we get a -2 plus 6 over pi, sine of u. Go ahead and substitute back in our u value, and we're just going to check this thing out from 0 to 4. Okay, let's see how far they want us to take this. I guess we probably need to clean this up. We want to get some points on this. So -2 stays along, and 6 over pi at a sine of what? Pi over 6 at 4 seconds minus 6 over pi sine of 0. Well, this is lucky for us, I suppose, that sine of 0 is what? 0. And this becomes the sine of 2/3 pi, which we already found earlier to be positive square root of 3/2. So we have square root of 3/2 times 6 pi plus a negative 2. Cleaning this up, 6 and a 2 reduces to what? 3 and 1. So we have 3 square roots of 3 over pi. And I suppose we could probably stop right there. Should get our points for that. Alright, so this is just an example of a non-calculator section. I'll do one with the calculator next, so you get a little practice with that too.